In question number 9, we have to first establish the secant ratio. And the secant ratio is essentially the reciprocal of the cosine, or 1 over cosine. Now, using that ratio, if we test tan squared 33 degrees plus 1, we'll see that that will be the same as secant squared 33. And the same for tan squared 52 plus 1 is going to give us secant squared of 52 degrees. So looking at this, we can test a few more angles, but we essentially should be able to generalize that the tan squared plus 1, just like we have here, tan squared plus 1, that's going to be equal to secant squared theta. Now, this is following a lot like Pythagoras. In fact, it is Pythagoras. So if we have tan squared plus 1, we can kind of rewrite this as tan squared plus 1 squared. And we can see that it really does follow Pythagoras theorem. So there must be some line tan, a line of length 1, and a line that is a secant line. So if taking a look at the circle, so part D says we have a circle of radius 1. Okay, so there's a radius 1 circle. Along the horizontal, we have 1. The tangent line is that vertical line that is tangent to the circle. That's why it's called a tan line. So this line here, this length from here to here, represents the tangent length. And if that's the case, we have tan squared plus 1 squared equals secant squared. Well, we have Pythagoras that tan squared area, area of 1, it must equal the secant squared area. Well, that's the same as the area of the hypotenuse. So this is secant squared theta. That makes the length of the secant line, this line here. That line then represents secant theta. That green line, the length of that green line that connects from the center of the circle to the end of the tangent line is called the secant line.